Step-by-step CNC part making, start to finish. What if I told you a perfectly designed part can still fail? Not because of the design, but because of one missed step in the CNC process. No loud warning. No visible mistake at first. Just wasted material, broken tools, and lost time. So here's the real question. How do professionals go from raw metal to a flawless CNC part every single time? Let's break it down step by step. 1. Understanding the requirement, the foundation. Every CNC job starts with clarity. You need to fully understand dimensions, tolerances, material type, surface finish requirements. Even a 0.01 mm mistake here can ruin everything later. This is where most beginners rush and regret it. 2. Material selection, strength matters. Choosing the right material isn't just about availability. It affects tool wear, cutting speed, final strength. For example, aluminum easy to machine, mild steel balanced strength, stainless steel tough but tricky. A wrong choice here is equal to higher cost plus poor finish. Personal computer 3. CAD design, turning idea into model. Using CAD software, you create a 2D or 3D model of the part. This is your digital blueprint. Key focus, accurate dimensions, proper geometry. Avoid unnecessary complexity. Because the machine will follow exactly what you design, no thinking, no correction. Gear 4. CAM programming, brain of the operation. Now the model goes into CAM software. Here you decide tool paths, cutting strategies, speeds and feeds. This step converts design into G-code. One wrong feed rate, and you are either breaking tools or burning material. Nut and bolt 5. Machine setup, where precision begins. Before hitting start, load the correct tools. Set tool offsets. Fix the workpiece securely, clamping. Set 0 point, work coordinate system. Loose clamping is equal to vibration. Wrong 0 is equal to scrap part. This step separates amateurs from pros. 6. Dry run, the smart check. Never trust code blindly. Run the program without cutting, check tool movement. Look for collisions. Verify positioning. This single step can save thousands in damage. Fire 7. Actual machining, moment of truth. Now the machine starts cutting. Watch closely, chip formation, sound of cutting, temperature, heat control. Good machining sounds smooth. Bad machining sounds like trouble coming. Time. What if I told you a perfectly designed CNC part can still fail? Not because the design is wrong. Not because the machine is bad. But because of one tiny missed step. No alarm. No warning. No visible mistake at first. Just crossmark wasted material. Crossmark broken tools. Crossmark and lost time. And sometimes thousands in loss. So here's the real question. Why right pointing backhand index? How do professionals go from a raw block of metal to a flawless, repeatable CNC part every single time? Let's break it down. Step by step. 1. Understanding the requirement, the foundation. Before machines. Before tools. Before even touching metal, you need clarity. Because CNC doesn't forgive confusion. You must fully understand exact dimensions. Tolerances, how precise. Material type. Surface finish requirements. Here's the truth most beginners ignore. white right pointing backhand index, a 0.01 millimeters mistake here becomes a 100% failure later. Pros don't rush this step. They study drawings. They ask questions. They double-check everything. Because once cutting starts, there's no undo button. 2. Material selection. Strength decides everything. Now comes the raw material. And this is not just pick what's available. Material affects tool life, cutting speed, heat generation, final part strength. Let's make it simple: aluminum fast, smooth, beginner friendly. Mild steel balanced, reliable. Stainless steel strong but unforgiving. Pick the wrong material. White right pointing backhand index, you'll face faster tool wear, poor surface finish, higher cost, longer machining time. Smart machinists don't just cut metal, they respect it first. Personal Computer 3. CAD design, the digital blueprint. Now the idea becomes real digitally. Using CAD software, you build the model. This is your blueprint. And the machine will follow it blindly. No intelligence. No correction. No, this looks wrong. So your focus must be accurate dimensions, clean geometry, no unnecessary complexity. Here's a hidden truth: white right pointing backhand index overcomplicated designs is equal to harder machining plus more chances of failure. Simple, clean, precise. That's professional design. Gear 4. CAM programming, the brain. Now we move to CAM. This is where most failures secretly begin. Because here you decide toolpaths, cutting strategy, speeds, feed rates. And this step converts everything into G-code. One wrong number, just one, white right pointing backhand index, too fast is equal to broken tool. White right pointing backhand index too slow is equal to poor finish. White right pointing backhand index wrong path is equal to collision. This is not typing code. This is controlling force, heat, and motion. Professionals don't guess here. They calculate. Nut and bolt 5. Machine setup, where precision becomes reality. Now we step onto the shop floor. This is where theory meets reality. Before pressing start, now I want to hear from you. Speech balloon: which step do you think is the most critical and why? Or if you've ever faced a CNC mistake. White right pointing backhand index, what went wrong? Let's learn from each other and get better, one part at a time.